Hello, so today I will be talking about projectile motion that is launched at an angle. A projectile motion is a form of motion in which an object is thrown near the Earth's surface, and it moves along a curved path under the action of gravity only. The only force of significance that acts on the object is gravity, which acts downward to cause a downward acceleration. An example of projectile motion launched at an angle would be throwing a ball, kicking a ball, etc. Projectile motion is two-dimensional, but if we take the components of all the vectors vertically and horizontally, we can simplify it into two simultaneous one-dimensional problems, which is the vertical component and also the horizontal component. The vertical and horizontal components are independent of each other. We can also split the projectile motion into three parts: the beginning, middle, and the end. And then after that, we can analyze the vectors, which represents the displacement, velocity, and time at each of the stage. As you can see from the picture, the point at point A is the beginning, the point B is the middle, and the end is at point C. And also, since the path of the motion is symmetrical, the motion on the way down is the same as it is on the way up. The horizontal and vertical component of the projectile motion are shown here, where we can see the different displacement, velocity, acceleration, as well as the time at each of the points of the projectile motion. We can see that in the horizontal components, the velocity is constant and there is no acceleration. As for the vertical motion, we can see that there is constant acceleration. So then, by looking at the table, we are able to use the Savart equations of motions for both the horizontal and the vertical component of the motion. For the Savart part of the horizontal motion, since the acceleration is zero, so there is only one equation that we can use. And the equation is v equals to s over t, where v is the velocity and s is the displacement and t is the time. So it is velocity equals to displacement divided by time. In the Savart part of the vertical motion, there are four main equations that we can see from the left. But we can also split the motion into two parts, which is at point B and the point at point C. Since some of the equations are not very useful because some of them just basically say that 0 equals to 0, so then the most important ones are at the bottom three equations, which are also the highlighted ones. So now let's try to apply it into an example. A ball is thrown at an angle of 30 degrees to the horizontal at the speed of 20 meters per second. Calculate its range and the maximum height reached. So first, let's split the motion into two components, the vertical component and the horizontal component. We can see that the horizontal component is the same throughout the motion. And as for the vertical component, we can see that it first decreases to point B, where there is no velocity. And it then increases to point C, which the magnitude of point C is the same as the point A. We can see that the velocity of the horizontal component is 20 cos 30, and it will stay 20 cos 30 even till the point C. And for the vertical component, it is 20 sine 30, and it will also be 20 sine 30 at point C, but at point B, it will be 0. Now let's start with the vertical motion using the Sauvat equation to find the maximum height reached. So we know that the initial velocity is 20 sine 30 and the final velocity is 0 because it is at point B. And we also know that the acceleration is the gravity, so meaning it is negative 9.81. And since we know the initial and final velocity and as well as the acceleration, by using Sauvat, we are able to find the time and height of the motion. So first, we need to find the time. We can use the equation of A equals to V minus U over T, and after that we make T as the subject of the formula because we want to find the time, which makes it T equals to V minus U over A. And by using that, we will get the answer as 1 second. But because 1 second is only half of the motion, and because we want to find the time for the full projectile motion, to do that, we need to times 2 to double the half of the motion to get the time for the full projectile motion. And because we times 2 to 1, we will get the time as 2 seconds, which means that for the full projectile motion, we will get 2 seconds. And now that we have the time, we can find the maximum height reached. We can use the formula of S equals to UT plus AT squared over 2. In this case, we use time as 1 second because we only want half of the projectile motion because we only want to find the maximum height reached. And the maximum height reached is also at the point of 1 second, which is the half of the projectile motion. And so then by using the equation, we can get the maximum height reached as 5.1 meters. 0, we use the formula of S equals to D over T, where it is speed equals to distance over time. And we make D as the subject of the formula because we want to find the range, which is distance in this case. So distance equals to speed times time. And because we know that the speed that is 20 cos 30 and the time is 2 seconds from the vertical motion. The reason here that we use 2 seconds and not 1 second is because we want to find the range, which is the distance of the full projectile motion and not the half of it. So then we use 2 seconds instead of 1 second. And the answer we get is 34.6, so meaning the range or the distance for the full projectile motion is 34.6 meters. When solving a projectile motion problem, you don't really need to remember a lot of equations. You just need to understand how to apply the Sauvat equations to the two components, the vertical and horizontal component of the projectile motion. So basically, just know the Sauvat equations. Thank you for watching and hope you enjoyed.